Hi, everybody. I'm happy to have something to show you about lists. I hope everybody's okay. I know a lot of us are pretty nerve-wracked with what's going on, and I hope you're not struggling with that. I hope everybody in your family's okay and that you're managing your new schedule and this crazy online world that we are suddenly in. So, I want to talk about what we just briefly go over what we talked about last time before break. We started talking about lists, and then we're going to move on from what we covered, which was talking about the array-based list, and start talking about the linked version of the list. But before we do that, let's just remember that the list is an extension of the collection. So the list interface extends the collection interface. So it includes all the methods of the collection and then some additional stuff. There's one main thing that all lists have that collections don't have, and that is an iterator. So with a collection, we have no way to loop through the collection and access every element of the collection. And in all of our lists, we are going to have that ability. So we will have the ability to iterate through the collection, and you will see how we do this later. Okay, so then we have several different types of lists. The most basic is the unsorted or unordered list, which is like a collection, plus it has an iterator. So things are put in whatever order the list software feels is most efficient. One of the lists that we're going to cover is an indexed list. So in an indexed list, each item has a position, like a subscript. This is similar to the built-in ArrayList class in Java, although it doesn't necessarily have to be array-based. So we have the collection methods, we have the iterator, and then we have some index-based options that allow us to access and update items based on their position. And then the other type of list that we're going to cover is a sorted list, and it has an iterator, but also in a sorted list, the list methods make sure that the list stays in order. So when you add or remove something, the entire list will still be in order. And that's something that we will talk about. How do the list methods know how to put different types of objects in order? So what we did before spring break was we talked about the list interface and the new methods, add and remove based on the position rather than the value, the key field, like we did in the collection. Set and get methods that allow us to change the item in a specific position or access the item in a specific position. And then index of, which allows us to search for an item and see where it is in the list. So we get back the index, the position of that item. And so what we did last time was we did this practice on, given these specific list operations, what would the array look like? The num elements, the fields inside the list, what would they look like? And then we did some implementation practice. So we tried to write some code to look at putting an element into a specific position. And I will give you a version of that you can look at. I would like you to also do this practice, which I don't think we did before break, where given a location, you're going to remove the item in that position. So rather than go through all the code of the list class, we just practice those most key add and remove operations. So on to the link-based list. So the fields in the link-based list are very similar to the fields in the link collection, but what we have is two references. One reference that points to the first item in the list, and one reference that points to the rear, the last item in the list. That is similar to what we saw in the linked queue. We still have num elements. And then we have some variables that are set and used by the find method. So if you remember from our collection, the methods such as add, remove, get, contains, and index of all need to search for an item in the list, and these fields are set by the find method, and then they can be used by those other methods. So what would our list look like if we do this at, this little practice? What would the list look like? Draw the front, rear, and the list nodes and put in the info fields. So you can see some of these are using the add similar to what we used in the collection. Some of these are using the index-based methods based on working with the position of the item. In order to do this practice, you need to know one thing about the way that the methods are implemented, and that is that when you do an add in the linked list, if you don't specify a position like this, it will add it at the end. So any add without a position specified, you will add it at the end. So you can practice that. And actually, my suggestion is that you stop this video, go ahead and do that practice, and then resume. Same thing with the previous exercise where we were doing a simple version of the remove method. Stop, do that, and then come back. Okay, so the next practice is practicing with some code with the linked list. So the first one says, add the new element in a specific position. And the second one says, remove the element in a specific position. So let's see if I can switch over. This is all experimental for me as well as you. So let's see. Here's my one-line whiteboard. It was a lot easier doing it on the whiteboard in class, that's for sure. Okay, so we'll assume we have some info here. Maybe well, let's see. I'm going to leave out the quotes, but let's assume these are strings. Let me try my other pencil. That's not what I wanted. It's been raining all day. So, okay. So, we're talking about adding a new item. So, here is rear. Oof, the writing's not coming out too well. Here is front. Okay, so, boy, that looks terrible. So if we want to add a new item in a specific position, so the position numbers start from 1. And if we want to add in a specific position, remember, we need to create the node. So we need an LL node, which means that we need a reference so that we can use that reference to do a new. I would write new node, but since my writing is so bad, I'm going to use something shorter. We'll call it temp. So we need to do a new node. In the new node, we will pass in the info, and then we need to link this in. So if we are going to add this in position 2, for example, that means it has to go in between these two. And the one that's currently 2 is going to end up moving down to be in position 3, and all the rest will move down 1, 2. So if we want to add in position 2, we need to find the item in position 1. And then we can link this one in after that. So that's my bad drawing to give you some hints on how to do that first exercise, right? Add the new element in position loc, and we're assuming that the location is valid. In the actual class, it has to check if the location is valid because we can't have any gaps. And if it's not valid, then it needs to handle that error condition. But we're going to do a more simplified version. Okay, the next one is we want to remove the item in position loc. So loc in both cases is going to be our parameter. In the add, right, we're going to have 2 parameters, the element of type T that we want to add, and then the loc is the int, the location where we're adding it. And in this one now, we just need the location, so the integer, which position we want to remove. Okay, so when we think about removing